Hey, deep divers. You ever wish like you had a friend, a friend who could like talk like a computer from your favorite video game?
Uh-huh.
Well, guess what? This deep dive, we are diving into the world of LLMs,
Yeah.
which stands for...
Yeah, large language models.
They're so cool.
They're like the super brains behind all those chatty video game characters and even some really helpful online assistants.
That's right. And we actually like read a bunch of research papers about them.
Oh, wow.
And don't worry, we're going to make it way more fun than homework.
Okay, phew. Because homework, not so fun.
Yeah.
LLM's much more fun.
Yes. It's like if you opened up one of your toys like a robot and you could actually like understand how all the gears and the wires work to like make it move and talk.
That's what we're going to do with LLMs today.
Yeah.
Awesome. Okay, so first things first, LLMs are huge EE.
Huge.
And I don't mean like the size of a giant robot, although that would be cool. I'm talking about billions, even trillions of tiny parts all working together. It's kind of like, imagine you had like a Lego castle.
Ooh, I love Legos.
Yeah, me too. And like it was even bigger than your house.
Whoa.
In each Lego brick helped the LLM understand how to use words and sentences.
Wow. So each of those little Lego bricks is like
a little piece of information.
A little piece of information. That's a lot of Legos.
Yeah.
So how do they learn to understand all those words? Do they go to like a special robot school?
Not exactly a school, but they do have to learn from somewhere.
Okay.
It's kind of like if you read every single book in your school library, plus all the comics and websites you could ever want.
Oh my gosh, that's a lot of reading.
It's a lot of reading.
Like way more reading than I want to do.
Way more reading.
So they're like the ultimate bookworms. They just like read all day long.
Pretty much. They're like reading champions.
Okay.
Yeah.
That makes sense. But how does reading all that stuff actually teach them anything? Is there like a teacher LLM telling them what's right and wrong?
Well, that's where it gets interesting. It's not so much about being told what's right or wrong. It's more about spotting patterns, like a super detective of language.
Ooh.
They look for connections between words and sentences and figure out how things fit together.
So like if I say once upon an the LLM might guess that I'm about to say time?
Yes.
Because it's seen that pattern in tons of stories before.
Exactly. Like it's a giant puzzle.
Yeah.
And the LLM is putting all the pieces together to understand how language works.
That's so cool. So are they just guessing all the time, or do people like help them learn too?
That's a great question. While they're really good at figuring things out on their own, people do play a big role.
Okay.
Remember how we talked about LLMs being like giant Lego castles?
Yeah.
Someone still has to build those castles. Someone has to tell the LLM what to do with all those Lego bricks, or in this case, all those words and sentences.
So it's like people give them the building blocks, and then the LLMs use those blocks to like build amazing things with language.
That's a great way to put it.
Okay. Cool.
And just like you can build all sorts of things with Legos, people can train LLMs to do all kinds of cool stuff.
Like what?
Like write different kinds of stories.
Oh, cool.
Translate languages so you can understand people from different countries.
Bro.
And even write computer code.
What? So they can do my homework for me?
Well, not exactly. It's a little more complicated than that. But they can do some pretty amazing things.
That's so cool. So it's like having a friend who's like really good at building Legos, but instead of building castles, they build awesome things with words and sentences.
Yeah, you got it. And it gets even cooler. Some LLMs can even use tools.
Ooh. Yeah. Hold on. Tools?
Yeah, like tools. Like a calculator.
They can use a calculator?
Or calendar. To give you even better answers. It's like having a friend who's also a walking encyclopedia.
Okay, so not only can they read like every book in the library, they can use tools too.
Yeah, they're like little robot helpers.
Robot helpers. I like that. It's a good one. Okay, so how do people actually teach LLMs all these cool tricks? Is there like a secret robot handbook or something?
Not quite a handbook, but it is pretty cool.
Okay.
One way is called supervised learning, which is kind of like when your teacher gives you practice problems in school.
I don't like practice problems.
Well, nobody really likes practice problems, but it helps you learn new things.
Okay, true.
It's like the LLM gets a bunch of homework, but instead of like math problems, it's word problems.
Oh, word problems. Okay.
Yeah.
I get it. So what do those word problems look like?
Okay, so imagine you're showing the LLM a picture of a cat.
Okay, cute.
And you're saying, this is a cat.
Okay.
Then you show it a picture of a dog and you say, this is a dog. And you just keep showing it all these different pictures and telling it what they are. And the more examples it sees, the better it gets at telling the difference between all those things all on its own.
Even if it's never seen that exact picture before.
Exactly.
Oh, wow. That's really cool. Okay. But what about those other tricks like using tools? How do they learn that?
Well, that's where things get even more interesting. There's another way to teach LLMs called reinforcement learning. Have you ever played a video game where you get points for doing something good?
Yeah.
Like rescuing a princess or collecting coins?
Yes. I love those games.
Well, it's kind of like that for LLMs, except instead of getting points, they get these like little digital rewards.
Ooh. Like digital cookies.
Yeah, you got it. And every time they complete a task correctly, they get a little reward.
So it's like the LLM is playing a giant video game, but instead of rescuing princesses, it's learning how to use a calculator or understanding a calendar.
Exactly. And the more rewards it gets, the better it becomes at figuring out how to do those tasks all on its own.
Okay, that is super cool. I have a question, though.
Yeah.
If LLMs are learning from all this information, like all this stuff that we're giving them, how do we know they're learning the right things? Like, what if they learn to be a little mischievous?
Ooh, that's a really important question.
Right.
And it's something that all these scientists are working really hard to figure out.
Oh, okay, good.
Because remember how we talked about people being the ones who train LLMs?
Yeah.
Well, it's like teaching your pet hamster a new trick.
Oh my gosh, I love hamsters.
You want to make sure it's a good trick, right? Not something that's going to cause trouble.
Right, you don't want them to, like, escape or something.
Exactly.
Okay.
We want LLMs to be helpful and well-behaved, just like your hamster.
Okay, so it's like an LLM hamster. Got it.
And that's why people are always working on new ways to train LLMs and make sure they learn to use their powers for good.
Okay, that makes me feel a lot better. So even though LLMs are super smart, people are still in charge of making sure they use their powers responsibly.
That's right. It's like having a superpower.
Ooh.
You need to know how to use it safely and for all the right reasons.
Like a superhero.
Exactly.
Okay, cool. So we know that LLMs are powerful learners. But is there a limit to how much they can learn? Can they get so big that they take over all the computers?
That's a question a lot of people ask.
Right. Scary.
Well, while LLMs are getting bigger and better all the time,
Yeah.
they do have some limitations.
Yeah, okay.
Okay, so one of those limitations is that they need a lot of power to run.
Oh.
Kind of like how a giant robot would need a lot of energy to move around.
Okay.
So it's like trying to plug a giant robot into a tiny little wall socket.
It's not going to work.
It's not going to work very well.
That's a funny picture to think about.
It's kind of funny. So all those trillions of parts need a lot of electricity to work together. So scientists are always trying to find ways to make LLMs more efficient.
So it's almost like they're trying to make that giant robot run on a single battery.
Yeah, exactly. And that would be a pretty amazing accomplishment.
Yeah.
And speaking of amazing accomplishments, our sources talk about all sorts of cool things that LLMs are already doing in the real world. Yeah, it's not all just reading books and playing video games.
Okay, I'm ready to hear about these LLM superstars. What kind of amazing things are they doing?
Well, imagine playing a video game where the characters could actually, like, talk to you
Whoa.
and, like, understand what you're saying.
No way.
That's already happening with LLMs.
Get out.
Yeah, they're making video games way more realistic and fun.
That's so cool. So it's
Yeah.
like having the characters in the game, like, come to life.
Yeah, exactly. And it's not just video games.
Okay, what else? What else?
LLMs can also, like, help doctors understand really tricky medical stuff.
Whoa.
So they can take even better care of people.
Really? So it's like having a super smart doctor friend who can read, like, millions of pages of, like, medical research.
Yeah,
Like in a blink of an eye.
pretty much.
Oh my gosh, that's amazing.
LLMs can help doctors diagnose illnesses faster
Oh.
and even come up with new medicines
What?
to help people feel better.
LLMs are like real-life superheroes.
I know, right?
But instead of capes, they have words and code.
That's a great way to put it.
That's really cool.
And here's another superpower. LLMs can even help you learn new things.
Like a superpowered teacher.
Yeah, you got it.
Whoa.
Imagine having an LLM that could create like personalized homework assignments just for you,
Whoa.
based on what you're good at and what you need to work on. No more boring worksheets for everyone.
That would be awesome. Wait, so LLMs can be doctors and game developers and teachers all at the same time? They sound unstoppable.
They're definitely becoming a big part of our world.
Yeah.
But remember, even though LLMs are super smart, they still need people
Oh,
to guide them
Yeah.
and make sure they're using their powers for good.
That's good to know. Yeah. So it's like having a super smart friend.
Uh-huh.
You want to make sure that they use their smarts to, like, help people and make the world a better place.
Exactly. And who knows, maybe one of you listening will be the one to create the next amazing LLM. It's a really exciting time to be learning about this incredible technology because they're already changing the world right before our eyes.
Yeah, they really are. Well, that's all the time we have for this deep dive. Until next time, deep divers, keep those brains buzzing. Welcome back to the deep dive. We're diving deep into large language models today, LLMs. You know them, but we're going deeper than the usual stuff.
Yeah, think of it like you've got the basics. Now we're getting into the really cool cutting edge research.
Exactly. So if you're already up to speed on LLMs, buckle up because we're about to uncover some seriously mind-blowing stuff. One thing that always gets me is the sheer size of these things. I mean, we've got LLMs now with billions of parameters, GPT-3, Megatron, Turing, NLG. These things are massive. But is bigger always better when it comes to LLMs? What do you think?
It's a question everyone's asking for a while. Yeah, more data, bigger models, that was the path. But, and this is where things get really interesting, researchers are finding ways to boost performance without needing a supercomputer the size of a city block.
Okay, now we're talking. So it's not just about building bigger and bigger models.
Not anymore. We're seeing incredible progress in something called efficient architectures.
Efficient architecture. So instead of just brute forcing it with size, it's about being smarter with how we design these models.
Exactly. Think about it like our brains. We don't use every single neuron for every task, right? Different areas specialize. LLMs are starting to work in a similar way. One fascinating example is mixture of experts, or MOE. Instead of using the entire massive model for every single input, MOE models only activate specific parts, the experts, so to speak.
So if I need an LLM to, let's say, analyze a financial report, it would only activate the parts of the model that specialize in financial language and analysis.
Precisely. And the results are really impressive. These MOE models can be just as good as the massive energy-hungry models, but using way fewer resources.
That's huge. Imagine having access to that kind of specialized AI power without needing a supercomputer. That's got to be a game changer in terms of making these tools more accessible.
Absolutely. And it's not just about efficiency, it's about adaptability. It's like instead of having one giant Swiss Army knife, we've got specialized tools for specific jobs.
I like where you're going with this. What other tools are in this LLM toolbox?
Well, another really promising approach is parameter-efficient fine-tuning.
Okay, break that down for me. Fine-tuning an LLM already sounds like trying to, I don't know, rebuild an engine while the plane's in the air. How can that be parameter efficient?
Great analogy. You're right. Traditional fine-tuning meant retraining the entire model, which takes a ton of computing power. But with parameter-efficient techniques, you're not retraining the whole thing. You only tweak small, specific parts of a pre-trained LLM.
So less of a complete overhaul and more like a targeted software update.
Exactly. This allows us to adapt these massive LLMs for specific tasks without needing as much computing power. Makes them way more accessible.
That's amazing. Taking something incredibly powerful and making it practical. I like it. Speaking of practical, let's talk about LLMs and coding. They can write poems, scripts, even compose music. We've seen it. But writing code, is that hype or is it the real deal?
It's the real deal, and it's a game changer. LLMs are getting really good at actually understanding and generating code.
Okay, that's impressive and honestly a little intimidating. What does this mean for the future of programming?
Big question, right? We're talking LLMs that can help you code, catch errors, suggest things. They can even generate entire functions.
I've played around with those AI coding assistants. It's amazing how they can speed things up. Are we heading towards a future where AI writes all the code?
It's possible we'll see some automation, which could free up programmers for more complex, creative tasks.
So not replacing programmers, but maybe empowering them to be more creative.
Exactly. But it's a valid question. What happens to jobs in a world with increasingly sophisticated AI? We've got to be thinking about that. And this is still early days.
It really makes you think, doesn't it? Where do we go from here?
That's what we're here to unpack. Understanding where this technology is headed and what it means for all of us, ready for the next level.
Absolutely. One thing that blows me away is the amount of data these LLMs are trained on. Scientific papers, code, the entire internet. How do they handle all that information without, I don't know, short-circuiting?
It's mind-boggling. And you're right, more data doesn't always mean a smarter model. Quality over quantity, right?
Right. So it's not just about throwing everything in an LLM and hoping for the best.
Definitely not. That's how you get bias, inaccuracies, and those weird hallucinations.
Okay, so how do researchers make sure these massive data sets are actually helping?
One way is to use curated data sets focused on specific knowledge. Like, there's a data set called Galactica that's specifically for scientific literature.
Like a special diet for AI.
Exactly. Another interesting thing is they're developing ways for LLMs to actually use external knowledge bases. One example is retrieval augmented generation, or RAG.
So instead of just relying on what they've been trained on, they can actually double-check their facts in real time.
Exactly. It's like giving them access to a massive library they can use anytime to check something or clarify a concept.
That's incredible. It's like having an AI assistant with built-in fact-checking. Okay, this next one might sound like we're stepping into a sci-fi movie, but I swear it's real. LLM-powered agents. AI that can understand and generate text, but can also act independently, make decisions, even work with other AI agents.
It does sound pretty futuristic, doesn't it? But it's real, and it's incredibly exciting.
So we're not talking about AI that just responds to our questions anymore.
Yeah.
These LLMs can set their own goals and take action to achieve them.
Exactly. Imagine AI that can use websites, use tools, navigate virtual environments, even control robots.
Hold on, not just virtual tasks. We're talking about LLMs potentially controlling physical robots in the real world.
That's the potential, yeah. Which raises all sorts of questions about ethics, safety, control. But the possibilities, AI working with humans, solving problems, automating tasks, even speeding up scientific discovery, it's amazing.
There's a lot to unpack there, that's for sure. Exciting, a little daunting, but definitely worth talking about.
I completely agree. It all goes back to the core of what we're discussing, the future of LLMs and what they mean for the world.
This is really just the beginning, isn't it? So much more to explore.
Oh, absolutely. We've only just scratched the surface of what LLMs can do. And as they keep evolving, so will our understanding of what they're capable of and what they're not.
And that's what's so fascinating. This field is constantly changing, with new discoveries all the time.
Exactly. And as we push those boundaries, we need to be responsible, think things through.
Well said. Okay, so far we've covered a lot in this LLM deep dive. New designs, code writing, those mind-blowing LLM-powered agents. We talked about ethics, limitations, and why it's crucial to have these conversations about AI and society.
It's been a great discussion.
It really has. But we want to hear from you, the listeners. What are your thoughts on where LLMs are headed? What excites you? What worries you? Share your thoughts with us, because this is a conversation that needs everyone's voice. And remember, as we head deeper into this world of artificial intelligence, one thing's for sure. The most important questions are the ones we ask together. Now, before we move on, I want to circle back to those LLM-powered agents. We talked about them controlling robots, but how does that actually work? 1 minute, they're processing language. The next, they're like moving things in the real world.
It's pretty wild, right? It's where language processing meets AI, meets robotics. It's all connected. Okay, but how?
Well, think of it like this. LLMs are great at understanding and giving instructions. So what if we could turn those instructions into actual actions?
So instead of telling me how to bake a cake, the LLM could direct a robot to actually bake it with like precise steps.
That's the idea. We're talking about robots that can understand commands like grab the spatula, scoop some batter, spread it evenly, that level of detail, bridging the gap between language and action.
That's incredible. The coordination, the understanding that would take.
It's mind-blowing. And it's not just about baking. Think manufacturing, healthcare, even space exploration. Robots doing intricate tasks, exploring dangerous places, all directed by LLMs.
It's like something out of science fiction, but it's real. What are some of the hurdles in all of this?
One of the biggest is safety, obviously. These robots are in the real world now, so any mistake could have big consequences.
Right. You wouldn't want an LLM to misunderstand and tell a robot to, I don't know, knock over $1 million piece of equipment. Exactly. So researchers are building in tons of safety measures, testing things carefully before letting these systems loose in the real world. Gotta push the limits, but do it responsibly, right?
Absolutely. So switching gears a bit, I'm curious about the training involved for these LLMs, especially the ones making decisions. We talked about the data sets, but what about the actual techniques? How do you teach a machine to think more like, well, not a machine?
It's a great question, and it's something we're constantly trying to improve. One really promising area is reinforcement learning.
Reinforcement learning, like training a dog with treats, but for AI.
You're getting it. Basically, you give the LLM a goal and then you reward it when it gets closer. Over time, it learns which actions lead to rewards and adjusts its behavior.
So if you were teaching an LLM to play a game, you might give it points for good moves and take away points for bad ones.
Exactly. And as simple as it sounds, it's been incredibly effective. We're talking LLMs playing complex games at superhuman levels.
That's wild. So are we all going to be playing games against AI now? Or are there more practical uses for this?
Don't worry, there are bigger fish to fry than becoming pro gamers. Reinforcement learning has applications everywhere. Robotics, finance, healthcare.
So back to those robot chefs.
Exactly. Imagine using reinforcement learning to train a robot to cook the perfect steak. Every time it gets the temperature and timing right, it gets a reward.
No more overcooked steaks. Sign me up. But seriously, training these LLMs, especially with something like reinforcement learning, it's going to take a ton of computing power, right?
Yeah.
I mean, you're simulating whole environments, running things over and over again. Is that even sustainable long term?
That's a really important point. The environmental impact of AI, especially training these large models, is something everyone's thinking about.
So it's not just about making LLMs smarter, it's about making them more eco-friendly.
Exactly. It's called green AI, and it's a big focus, making sure AI is powerful but also sustainable.
I like the sound of that. So how do you make an LLM more energy efficient?
Well, you can develop better algorithms, ones that use less data and computing power but get the same results.
Kind of like those efficient architectures we talked about, but for the training process.
You got it. And we can use more sustainable computing, too. Data centers powered by renewables, even exploring new types of computing that are inherently more efficient, like neuromorphic computing, which is inspired by the human brain.
Wow, so it's not just about the LLMs, it's about the entire system, the algorithms, the hardware, the energy sources.
It's everything. And it's going to take everyone working together, researchers, engineers, policymakers, even just people like us, to make sure AI development is both innovative and responsible.
It's a big challenge, no doubt.
Yeah.
But it's good to see that sustainability is a priority in the AI world. Okay, we've covered the technical side of LLMs, how they're built, how they learn, what they can do. But let's step back for a second and talk about the bigger picture. What do all these advancements really mean? What's the impact on society?
That is the question, isn't it? And it's one we need to keep asking, especially as this technology keeps changing so fast. These aren't just tools. They have the potential to change entire industries, automate jobs, even change how we think.
It's exciting, but it can feel overwhelming too, right? So much potential, but also potential risks.
For sure. And that's exactly why we need to be having these conversations, bringing the public into the fold, making sure that ethics and the impact on people's lives are at the forefront of all of this.
So it's not just about what LLMs can do, it's about what they should do.
Absolutely. We have to be thoughtful, make sure these technologies are used to benefit everyone, and that means getting input from everyone.
I agree. And part of that is just educating people, right? Demystifying this technology.
Yeah.
Having open and honest conversations about what could go right and what could go wrong.
Couldn't agree more. Knowledge is power, and the more we understand LLMs, the better prepared we'll be to use them responsibly and ethically.
Well said. And this deep dive is all about that, starting those conversations, exploring these big ideas in a way that everyone can understand.
Exactly.
But we're not done yet. There's so much more to uncover. You know, for all the amazing things LLMs can do, I'm also really interested in their limitations. Where do they fall short?
It's a great point. LLMs are powerful, but they're not magic. They definitely have limitations.
And understanding those limitations is just as important as celebrating all the cool stuff.
Right, absolutely. One of the biggest ones, and we've touched on this, is their lack of real-world understanding. They can process tons of info about the world, but they don't actually experience it like we do.
Right, like knowing about something versus actually doing it. Reading about riding a bike is a lot different from feeling the wind in your hair.
Yeah, they don't have those same physical experiences. The weight of something, the feeling of sunlight, those things are fundamental to how we understand the world.
So they can describe a sunset perfectly, but they might not get why humans find it beautiful.
It's like they're missing that emotional connection, that human element. They can tell you all about the physics of a sunset, the wavelengths of light, but the feeling it evokes, that's different.
It's almost comforting to know there's still things AI can't replicate. Reminds us that as smart as they are, they're not human.
Right. It's a good reminder not to get carried away with thinking they're just like us.
Okay, so real-world understanding, that's a big one. What else?
Common sense is another tricky area. LLMs can access mountains of information, but actually applying it in a way that makes sense, that's harder.
So they might know the capital of France, but they wouldn't know you don't wear a swimsuit to a job interview.
Exactly. They miss those subtle things, the unspoken rules that humans just get.
It's funny, right? They can do these incredibly complex things, but then trip up on something a child understands.
It shows just how complex human intelligence really is, and how much work we still have to do to truly replicate it.
Absolutely. It's a good reminder to be aware of their limits. Well, we've covered a ton today. We dove deep into cutting-edge LLM research, from how they're designed to code writing to those mind-blowing LLM-powered agents. We talked about ethics, about limitations, and about why it's so important to keep having these conversations about AI and its impact on our world. But now, we want to hear from you. What are your thoughts on the future of LLMs? What excites you? What concerns you? Share your thoughts with us on social media, because this is a conversation that needs everyone at the table. And as we move further into this incredible age of AI, remember, the most important questions are the ones we ask together. Thanks for joining us on the Deep Dive.
All right, listeners, today we're going deep, really deep.
Yeah, we're diving into the trenches of LLMs, the really technical stuff, so buckle up.
You got that right if you're here. We're assuming you know the basics.
Think of this as LLM architecture analysis, but with, some fun sprinkled in.
We're talking about 2 seriously dense academic papers on LLMs, and we've got graphs with exploding lines, the whole shebang.
Oh, yeah. Figure 2 in a comprehensive overview of large language models is a great example. The timeline of LLM releases.
It's like everyone and their chatbot is releasing an LLM these days.
But there's a pattern, right? It's not just about building bigger models anymore. It's about instruction tuning, open source.
Making them smarter, not just bigger.
Exactly, more accessible too.
Which reminds me, what about that whole debate, Jurassic-sized models versus, well, something a bit more?
Chinchilla-sized.
Yeah. The chinchilla model, it's smaller than Gopher, but it performs amazingly well, all because it was trained on a mountain of data.
It's a great example of why bigger isn't always better.
So it's like the tortoise and the hare of LLMs.
In a way, yeah, but it's not just about data size. It's about efficient training and avoiding overfitting, of course.
Right. Finding that sweet spot, it's tricky. One thing that blew my mind was this whole concept of instruction tuning. Like, you're teaching a massive neural network to follow instructions, like training a
hyperactive puppy.
Yeah, something like that. But seriously, giving them a crash course in structured thinking.
Exactly. And the results, they're mind-blowing. The paper talks about FLAN-PLM and MT0. These models can actually generalize to new tasks, even with zero-shot learning.
It's like they're developing LLM intuition or something.
It's pretty incredible.
Yeah.
Imagine giving an LLM a simple instruction and it just figures it out, even if it's never seen that specific task before.
Okay, now we're talking next level stuff. What about augmented LLMs? It's like giving them access to like a superpowered research assistant or something.
I get getting it. Augmented LLMs can tap into external knowledge, databases, APIs, even the entire internet. It's wild.
Okay, now that just sounds terrifyingly impressive.
It's pretty remarkable.
But wouldn't that slow things down, like, a lot? Accessing all that external data.
It could, but researchers are brilliant. They're finding workarounds. One really promising approach uses cross-attention to blend the retrieved information with the LLM's decoder.
Cross-attention? Okay, you're going to have to break that down for me. It sounds like some LLM mind meld or something.
Basically, it lets the LLM focus on what's important, ignoring the irrelevant stuff. All about speed and accuracy.
Like giving it a superpower to process information crazy fast.
Mm-hmm.
But, you know what they say? With great power
comes great responsibility, and LLMs are not perfect.
Yeah, they still hallucinate, making stuff up. Like, they haven't quite grasped what's true and what just sounds good.
That's the heart of it, right? We're training them on massive data sets of human language. And, well, let's face it, human language can be messy.
So how do you even fix that? You can't just tell an LLM to be more truthful. Or can you?
Well, there's some promising research on something called alignment tuning, using human feedback to train them to be more truthful and aligned with human values.
So like giving the LLM a conscience, or at least a really good BS detector.
Something like that. It's still early days, but the potential is huge.
It's pretty mind-boggling when you think about it.
It really is. The possibilities are pretty much endless with LLMs these days.
I'm ambitious, yeah.
One approach is using something called RLHF, reinforcement learning from human feedback.
RLHF, catchy.
Right. It basically trains a reward model to judge the LLM's output based on, well, what humans prefer.
It's like giving the LLM a conscience, or maybe like a really good BS detector.
That's a good way to put it. But it can be computationally expensive, so there's other avenues being explored, like aligning LLMs with supervised fine-tuning, or even using synthetic feedback from other LLMs.
Whoa. Using AI to teach AI ethics? That's getting meta.
It is, but that's where the field is heading. But for now, let's maybe circle back to instruction tuning.
Yeah, let's get back to that. The paper went into like the actual mechanics of it.
It's actually pretty elegant. A common method is fine-tuning the LLM on a data set of instructions, paired with input-output examples.
So like giving it a textbook of, if you see this, do that.
Exactly. But the cool thing is, those instructions, they're often in plain language. We're teaching the LLM to get the intent, not just memorize words.
Which explains how instruction tuning helps with zero-shot learning, right? Like, you can perform well on tasks it's never seen before.
Exactly. It's not just rote memorization. It's about learning underlying principles.
Like it's developing like LLM intuition. That's wild. Speaking of which, what about the different LLM architectures? It's like comparing blueprints for different engines.
It really is. You've got your encoder-decoder models like T5, great for translation, then your powerhouse causal decoders like GPT-3, built for generating text.
And then there are the more unique ones.
Right, like the mixture of experts approach used in GLAM, for example.
Mixture of experts? That sounds intense. Is that like multiple LLMs working together on one problem?
Exactly. Different experts within the model, each specializing in something else, and a router network that decides which expert to use.
So it's like strategic delegation within the LLM itself. That's clever.
It's a really clever way to scale up without insane computational costs.
Makes sense. So no one-size-fits-all architecture. It depends on what you're trying to do.
Exactly. And the papers do a great job of like breaking down the strengths and weaknesses of different approaches.
Okay, so shifting gears a bit here. Let's talk about training these models, because it's not just about like throwing data at them, right?
Oh, absolutely not. It's an art as much as it is a science, especially at scale. You've got massive data sets, complex architectures, so many things to fine-tune.
It's like tuning a high-performance race car. One wrong tweak and the whole thing explodes.
That's one way to put it. And these papers, they highlight some of the common pitfalls, like loss divergence.
Loss divergence, that sounds not good. What is that exactly?
Basically, it's when the model's error rate suddenly jumps during training, like the engine sputtering just when you think you're hitting top speed.
And how do you fix that? Like hit the reset button?
Sometimes, yeah. You might have to restart from an earlier point or adjust the learning rate, tweak the batch size, even revisit the data itself.
So it's a lot of trial and error, fine-tuning, intuition even.
It can be, yeah. Training LLMs is a fascinating mix of art and science.
For sure.
Yeah.
You mentioned earlier the importance of data quality. Can you elaborate on that? It's not just about the amount of data, right?
Right. You can train an LLM on all the text in the world, but if it's full of errors or biases, your model will be too.
Garbage in, garbage out, as they say. But it must be tough to spot the garbage in massive data sets.
It's a huge challenge. The papers talk about techniques like deduplication, quality filtering, and even privacy filtering.
Privacy filtering, that's interesting. What is that like, removing personal information?
Exactly. Especially important now with LLMs becoming so powerful. We need to be very careful about protecting privacy.
Right. We want knowledgeable LLMs, but not at the cost of people's privacy. That's a tough line.
It is. It really is. It all comes back to ethics, which needs to be a part of LLM development from day one.
Absolutely. Okay, let's shift gears again and talk about what these LLMs can actually do, the applications.
Now we're talking, and the possibilities are pretty much endless, honestly.
We've got chatbots, virtual assistants, language translation, content creation. It's already happening.
And the papers even mention scientific research, creative writing. It's incredible.
The LLMs are like amplifying human intelligence and creativity. It's wild.
They really are. And this is still early days. As these models evolve, we can expect even more transformative applications.
It's exciting and a little bit scary, to be honest.
It is, but in a good way, mostly. It's a whole new frontier.
For sure. Okay, so before we move on, let's talk efficiency. We touched on it earlier, but the papers really stressed how important it is, right?
It's absolutely critical, especially with LLMs getting bigger and more complex. Training and deploying them takes a ton of resources.
So it's about making them accessible too, not just powerful.
Exactly. And there's been some amazing progress. The papers talk about techniques like pruning, quantization, and knowledge distillation.
Pruning, like a bonsai tree.
Kind of. It's about removing unnecessary parts of the model to make it more efficient without losing performance.
Trimming the fat, so to speak. What about quantization?
That's about using less precise numbers in the model's calculations. It saves memory and speeds things up.
Like using a lower resolution image, but still getting the idea across.
Precisely. And then there's knowledge distillation, where you basically train a smaller, more efficient model to mimic a larger one.
Passing on the wisdom, so to speak.
Exactly. And often the smaller model can perform almost as well as the larger one, which is huge for efficiency.
That's amazing. This is great news for anyone who wants to use LLMs in like mobile devices or other limited environments.
Absolutely. It opens up a whole world of possibilities, and the papers really showcase just how effective these efficiency techniques can be.
It's fantastic to see such a focus on making LLMs more practical and accessible, not just bigger and more complex.
It's a testament to how collaborative the LLM community is. Everyone wants to see these models reach their full potential.
Absolutely. Speaking of potential, let's talk about specialized LLMs. We've been discussing general-purpose models, but there's a movement towards more specialized ones, right?
Definitely. We're seeing LLMs specifically trained for finance, medicine, law, you name it. They often outperform general-purpose models in their domain.
Like having a team of expert LLMs, each with their own specialty.
Exactly. And this trend will only accelerate as LLMs get adopted in different fields. Imagine LLMs for medical diagnoses, financial forecasts. The possibilities are huge.
It's a bit mind-blowing, to be honest. But one thing's for sure, LLMs are changing the game.
No doubt about it. And these papers, they're a roadmap for navigating this exciting new landscape.
For sure. Okay, so for our listeners who want even more, the full papers will be linked in the show notes.
And for those just starting their LLM journey, welcome. It's an amazing field. Dive in and explore.
Well said. This is a field that rewards curiosity and experimentation.
It absolutely does.
You know, it's funny, we talk about all these advanced concepts, but the papers really emphasize something pretty basic, the data.
It all starts with the data, right? Garbage in, garbage out, as they say.
Exactly. You can have the most amazing LLM architecture, but if the data is bad, the results will be too.
The papers go deep into data prep, different sources, cleaning methods, even the ethics of it all.
One thing that stuck with me was the need for collaboration. LLM researchers working with, say, medical experts if you're building a medical LLM.
Absolutely. Domain expertise is crucial. You need that human insight at the data level.
It takes a village to raise a really smart AI, I guess.
Something like that.
And speaking of data, the sheer volume these models are trained on is mind-boggling. We're talking terabytes, petabytes of text.
Table 8 in a comprehensive overview lists them out, the data sources, the sizes. It's pretty wild.
The PaulM model, 780 billion tokens. It's insane.
Yeah.
At what point does more data stop being helpful? You know?
Right, that's the big question. More data usually means better generalization, but there's always the risk of overfitting.
Where the model just memorizes instead of understanding.
Exactly. That's where data cleaning and filtering come in. Things like deduplication, quality filtering, privacy filtering.
Privacy filtering, yeah, what's that about?
Making sure no sensitive personal information leaks out, especially important now with LLMs being so powerful.
Right, we want them to be smart, but not at the cost of privacy. That's a tough one.
It's a balance, for sure. But it highlights how crucial ethics are in LLM development every step of the way.
Couldn't agree more. Okay, switching gears a bit, how do you even measure how good an LLM is? It's not like a standardized test, or is it?
Actually, there are standardized tests for LLMs. The field has developed tons of benchmarks and metrics. A comprehensive overview lists them in Table 9.
It's like the LLM Olympics. Benchmarks for language understanding, reasoning, problem solving, even creativity.
It really shows how versatile these models are. We're not talking about narrow AI anymore. LLMs are becoming more and more generally intelligent.
It's exciting and a little daunting at the same time, to be honest.
It is. We're on the edge of something big here. But these papers, they're a great guide for navigating this new world.
Absolutely. And for our listeners who want to dive deeper, we'll have links to the full papers in the show notes.
And for those just starting out with LLMs, welcome. It's an incredible field. Don't be afraid to jump in and get your hands dirty.
That's great advice. This is a field that rewards curiosity, that's for sure. Well, I think that wraps up our deep dive into the world of LLMs.
It's been a fascinating journey.
It really has. To our listeners, thank you for joining us on this deep dive into the fascinating world of LLMs. Until next time, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.